All right, let's talk about half-life. So there are things that grow exponentially, but there's also things that decay exponentially. And the most common one that we like to talk about is radioactive substances experience radioactive decay, which is exponential decay. But there's other things that experience similar decay. A lot of times, assets depreciate; they lose their value, but not by the same amount every year. It's this decay where they lose a lot of value at first, and then only a little bit of value after that. So sometimes this decay can be modeled exponentially. What half-life is the amount of time it takes for the amount to be decreased by half. So in this case, it says the half-life of nitrogen 16 is approximately 7.13 seconds. So after 7.13 seconds, we're going to lose half of this isotope of nitrogen. Well, how does half-life work? Well, it's the same kind of exponential growth slash decay we've been dealing with, but the base is going to be 1/2. We've got this starting amount, and we're saying, hey, I'm going to multiply it by 1/2 over and over and over. Every time we hit this certain time period, we multiply it by 1/2. Well, that time period is here because, like, for example, let's say that the half-life was 10 seconds, okay? Well, how often should we cut this in half? Well, it should be every 10 seconds. So if we hit 10 seconds as our time, this says we're cutting in half once. If we hit 20 seconds, we're going to cut this in half twice. Okay, so that's why this is here in the formula. All right. So let's just use the formula. Let's see if we can figure this guy out. So our starting amount. Well, let's say we have 3 grams, and we want to see how it decays over 8 seconds. Okay, well, we can put the 3 in for our initial amount. Our time is 8 seconds. Our half-life is 7.13 seconds. So that's pretty straightforward. We plug that in, we get approximately 1.3784 grams. Now let's see if this makes sense. So I've got this 3, and after 7 seconds, approximately, it should be cut in half. That'd be like 1.5. We're going a little bit above that, so we have a little bit less than that. So this answer makes sense. Okay. Now, something else that it asks us to do on our homework is to convert this into something of a slightly different form. And you might say, well, how am I going to convert it to something where you don't need the H here? Well, let me show you the trick to this, okay? So first of all, don't worry about this in front because that's going to stay the same. So what we have to do is rewrite this as this. You're like, wait, what's going on here? Well, all I'm doing is, you know how whenever these are on when I do an exponent of something with an exponent, I can multiply these. Well, I'm kind of undoing that process. T times 1 over H is this guy. So I'm just kind of separating these guys. Okay? And this H, we already found, this is 7.13. So I'm going to take 1/2 to the 1 over 7.13 power. And this is going to get me, I calculated this earlier, 0.907360. wants us to go to 6 decimal places because your precision here is a lot more important because exponential growth is really sensitive to what your base is. So this and this are approximately the same thing. It would be exactly equal if I had, infinite decimals to go here. So again, we take out this 1 over 7.13. We go ahead and take that exponent, and we get an equivalent exponential expression. Technically, we should be able to plug in these numbers and get the same values. I'm not going to do that for you, but you should get the same value that we got before.